Good day again. Welcome back to Central Washington University's Cornerstone program. I'm Jeremy Beckman and I teach at Natchez Valley High School. Today we start chapter 5, which is exponential functions and exponential growth. Later on in the chapter we talk about logarithms, natural logs, talk about solving exponentials, but today we're going to start out section 5.1, which is talking about exponential functions. So let's go ahead and take a look at the PowerPoint first. Let's talk about what we want to roll through today. With section 5.1, we're talking about exponential functions. What do we want you to learn today? We want to first off review all those properties of exponents that you either learned in Algebra 2 or in Core 3, whatever you had before this class. We're going to identify the properties of an exponential function on the graph, and then we're going to use those properties of exponentials to solve equations. I'll give you just a second to write those down. We're going to start today with a classic math problem. I always like to start with a problem that really kind of goes through what we're going to talk about in this chapter and also kind of exposes the power of what we're going to talk about today. If you've taken Math 101, we spend almost an entire section on this problem, but we'll talk about it today just because it's an interesting problem. And to get started, your parents, being as mean as they are, you work all day and all night to get your straight A's, even though you're taking college credit math courses in high school. However, they're not going to buy you a car because it's too expensive. The insurance is too much, the gas is too much. However, you propose an idea to them. You say, Mom, I just want you to start me out with an allowance of 1 cent, and then I want you to double that amount every time I turn in A math homework. Question to you today, how many days until your parents give you enough money on that day to purchase a 2012 Ford Mustang, which just from the Ford website has a manufacturer's price of $27,130? So in a group, partner up with somebody here on campus or in the Distance Learning Center, choose somebody next to you. First, I'd like you to just take a guess. How long do you think this is going to take? How many years? How many decades? How many months? And then I want you to try to model this equation. What can we do to type this into an equation, to use our calculator, or to use just pen and paper to be able to figure out how long is it going to take until Mom and Dad give us enough money on that one day for us to purchase that brand new car? On campus, any guesses? Okay, we got 3 years. Any other guesses from those of you on campus here? Go ahead.
1 year.
1 year? Okay, let's take a look. First off, how much do we start with? What do we get from our parents on the first day? And I'm going to bring up a graphing calculator to take a look. On the very first day, let me quit out of my equation here. On the first day, we get 1 cent. So we get 0.01. Now, every single time we turn in math homework with an A on it, our parents double what we get. So what do we have to do to that 1 cent to get how much we're going to get tomorrow? In other words, now we got 1 penny. What do we have to do to find out what we get next? Yep, we have to double. We have to multiply by 2. So on the second day, we have 2 cents. Now you might say to yourself, okay, this is going to take forever. This is a worthless math problem. Let's take a look and see what happens. Hit enter again. That's day what? Okay, that's our third day, so that's the third time we've turned in A math homework. Here's our 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th. Now just on day 15, we got $163. So okay, day 15, we're doing pretty good. 16, 17, 18, 19, 20, 21, 22. Now, is this the correct answer? Is this actually where we get it? Nope, we got to go one more day. 23. Day 23, we got $41,943.04. So just imagine that. You guys do your homework for 23 straight days. You get a brand new Ford Mustang. Now, that doesn't include all the good stuff. Probably doesn't have the GPS, the Bluetooth enabled and everything. But just think that. 23 days, you get $41,943.04. Now, to talk about what we're going to talk about in this chapter, that's the power of exponential growth. It doesn't start out very quickly. Those first few days, we just got pennies, pennies, pennies. But it explodes as the X increases or as the number of days you turn in your homework increases. Let's take a look at it just before we even go a little bit further. Let's take a look. How can we model this in an equation? So as we learned in chapter 4, we talked about taking a situation, writing an equation, and that's the power of math. Once we have that equation, we can do a ton with it. What did we start out in this example? We started out with 1 cent. And what did we do to that penny? We multiplied it by 2 a certain number of times. So we multiplied it by 2 x number of times, or to the x power. So let's take a look at our equation, our graph, our table as we go through that. Let's hit enter. First off, let's look at the table. Those are the values we are getting. And let's take a look at the graph real quick. Let's go to Zoom Standard again. So go to Zoom 6. And hit that again. Go to Zoom 6. Let's look at our graph. So notice, as x is small, the number of days, like the pennies we saw, it's very close to the x-axis to 0. Then as it starts to go out, it has that incredible jump in slope where it's just exploding upwards. That's the power of exponential functions. That's the power of what's happening in this chapter, is once they start going, they really increase at a quick rate. Let's take a look at what else is in this section. We had that classic math problem. Only 23 days worth of homework and you'd have that brand new Ford Mustang. Probably your mom and dad would drop their jaw when they saw how little time it would take. Now it is important to note in that problem, that's not the total amount of money you got, that's just the amount of money you got on that day. So imagine on just that 23rd day, your parents had to write you that $40,000 check. That's an expensive homework assignment. Let's take a look at what's in this chapter. First thing we want to do, from Algebra 2, from Core 3, we want to review all of those properties of exponents that we learned and we reviewed with that. First off, if a is any real number, if you have a raised to a power, and that entire quantity raised to a power, what's that equal to? That's equal to a to the x times y. A to the x times a to the y is equal to a to the x plus y. So in other words, if we have two terms with the same base, to find what those are equal to combined, you add the exponents. To reverse that, or just the opposite, if you have a to the x over a to the y, that's equal to the subtraction, or the difference between those two exponents, provided that a is not equal to 0. If you have a negative exponent, a to the negative x, that's equal to 1 over a to the x. And then possibly the most important part, because we're going to prove a lot in this chapter, the most important part might be that if you have the same base raised to one power equal to the same base raised to another power, that implies that the two exponents are equal to each other. In today's work, and the problems we're going to work on, that's probably the most important property of exponents that we're going to talk about. Give you a second, just copy those down. Here you are on campus. Just as you're copying it down, let's talk about why is it important that a can't be equal to 0 in those two middle terms. What would happen if a was equal to 0? Go ahead. Yeah, if a is equal to 0, the denominator is equal to 0, the fraction is undefined. Good. Okay, let's get down to some work here. Let's talk about first review problem, a problem that might seem impossible at first, but let's use some properties of exponents to review. We have 9 to the x is equal to 27 squared. Oops. Now let's take a look at the doc-cam, talk about this problem. So we have 9 to the x is equal to 27 squared. Now, thinking about those exponent properties that we just reviewed, which one of those could apply to this situation? But you're saying to yourself, none of them. Why? They don't have the same base. Well, think of 9 and 27. Do they have a common base, or is there an exponent you could raise both to? Because really what we'd like is b to some power is equal to b to some other power, and then those two powers are equal to each other. So 9 and 27, what do those two have as a common base? They both have 3. You'll be reminded that 9 is equal to 3 squared, and that 27 is equal to 3 to the third power. So substituting that in, I'm going to use some parentheses just to keep things clean. We have 3 squared. That replaces 9. We raise that to the x power. 27, replace that with 3 cubed. Now we see, okay, I got the same base of 3. Now we can work through this problem. Reviewing again the properties of exponents. If you have a power raised to a power, multiply those powers. So 3 to the 2x is equal to 3 to the 6. And then again, using that last property, possibly that most important property, 3 to the 2x is equal to 3 to the 6. Therefore, 2x is equal to 6. And the easy part, how do you solve that for x? Divide both sides by 2. Again, making sure both sides are kept equal. And the one number you can plug in to make both sides equal, plug in 3 for x. If you want to verify that, of course, if your life depends on it, you want to make sure your answer is right because you want to get that Ford Mustang by getting the A on that math homework. Plug 3 in for x. 9 to the third hopefully will be equal to 27 squared. That'll verify your solution. Instructor on the Cornerstone program, go ahead and maybe stop for just a sec, take questions. Anybody on campus, questions on that? All right, let's roll back to the PowerPoint. Let's take a look at another example. Another seemingly impossible problem at first, but let's see what we can use the properties of exponents for to go through this. We have the square root of 3 raised to the power of 1 plus the square root of 3 times the square root of 3 raised to the power of 1 minus the square root of 3, and somehow we need to simplify that answer. Impossible, you say. Let's take a look at this one. Let's roll the dot cam. So we have the square root of 3 raised to the power of 1 plus square root of 3 times the square root of 3 raised to the power of 1 minus square root of 3. Now, this one we're probably hoping somehow square root of 3 gets canceled out of there, somehow we get rid of that. For my students, I always tell them, okay, if you don't know where to start on this one, let's try to make it an easier problem, see what happens there. Because to be honest, most students are going to struggle with that square root of 3 on the inside. That's going to block them from being able to see it. So let's rewrite the problem just in a little different version. Let's replace square root of 3 with a. So we have a to the power of 1 plus square root of 3 times a to the power of 1 minus square root of 3. So we have a base to a power times a base to a power. What do you do with those exponents? You add those puppies together. You combine those by adding. So let's go back to our original problem. It's the square root of 3 raised to the power of 1 plus the square root of 3 plus the second exponent. So in other words, to get rid of those exponents, or to combine those together, we need to add those because they're the same base multiplied together. Nice part of this, positive square root of 3 cancels out the negative square root of 3. 1 plus 1 gives you 2, so you have the square root of 3 squared. And just to review a simple law of exponents, when you have a square root, how could we write that as 3 to a power? How could we write that as 3 to a power? Okay, you could write that as 3 to the 1/2 squared. Take our two powers and multiply them. 1/2 times 2 gives us 3 to the 1, which is just 3 for the solution. See a lot of inquisitive looks here on campus. Questions on that?